Good afternoon. Jim Wade's here. Today we're going to talk about how to adjust the 200 series non-vital Pintsch wheel sensor, also commonly called the Tiefenbach wheel sensor. So generally speaking, Pintsch manufactures several different types of sensors. But in the case of the 200 series and the 400 series, they're slightly different. Over here you can see this one's gray, and that indicates that it's a 200 series non-vital wheel sensor. The blue sensors are a vital wheel sensor. These are typically used in non-vital applications. These are typically used in vital applications, for example, grade crossings, interlockers, trap circuits, wayside signaling applications, etc. The appearance is very much the same, and the structure and electrical behavior is very similar. However, there are some critical differences, one of which this has two sensors that are always looking at the web of the rail to provide off-rail detection. That way, if this is displaced from the rail by more than, say, for example, a millimeter, perhaps it's been damaged by on-track equipment or maintenance of way activity, it will provide a fail-safe signal to an axle counting system to ensure that a train can't enter a vital circuit without being detected. So again, vital and non-vital. Okay. Generally speaking, they're not interchangeable. As a matter of fact, they're never interchangeable. These are operated at a different voltage level, okay, than these. These operate at about 10 volts. These operated at 8 volts. Okay, so you cannot interchange these sensors. But the structure is similar. They're both double wheel sensors. You can see sensor 1, sensor 2, sensor 1, sensor 2. They both have two pair. Okay, and they're both color coded the same. So for example, sensor 1 is brown yellow. Okay, well, you can see that. Sensor 2 is green white. So very similar. They both also have these tuning ports on the bottom. Okay, and you have to adjust them when they're first installed and periodically for maintenance. So you take out these nylon nuts, and then you have this spring-loaded cam here that allows you to access the tuning port. Okay, and so it's spring-loaded for a reason, and that is when you're not adjusting it, the spring pushes this out and it locks the adjustment in place so that the vibration from passing on-track equipment will not eventually push the sensor out of its proper adjustment range. So to adjust, you take the adjustment device, you push it in, okay? When you push this in against the spring and you hold it, that releases the cam and allows you to adjust the sensor. And again, make sure you push up when you're adjusting it so that you don't damage the adjustment device or the wheel sensor itself. So again, very similar, but remember that they're different sensors and they have different standards in electrical behavior. And therefore, the test device that we use with them is different. This sensor uses the R58/117 test device. Okay. The blue sensor uses the R58/117/1. Again, different voltage levels, different characteristics. You have to use the correct gray box here with the LEDs, okay, to make sure that you're not adjusting the sensor with the wrong device. So again, make sure you use the correct adjustment device, the correct R58 device with the correct sensor. Okay. So basically what you do is you take that R58 device and it basically has color-coded clip leads. You connect those 4 color-coded clip leads to their matching pairs here on the sensor at the junction box, for example. And then you make sure the internal equipment that it communicates with is disconnected. So you, for example, open the test links or gold nuts or disconnect from the field, okay, so that this is the only thing connected to the sensor. Okay, so in other words, you can't have this connected to the sensor at the same time it's talking to a relay house or a yard or tower and communicating also with the G84 or G94 switching amplifier module. So again, disconnect the sensor electrically from the field, from the infrastructure, and connect this in its place by matching the 4 colors, brown, yellow, green, white, and you're pretty much ready to test. So what I'm going to do now is I'm going to go ahead and adjust the sensor. So bear with me for a moment while I kind of focus in. And again, I don't have a videographer or a cinematographer or anybody like that to kind of make this a little more polished, but hopefully you'll get the technical information out of it that you need. So, you can see I've got an oscilloscope connected across one of the sensors and an analog meter here across the other. Again, it's a double wheel sensor, and this will allow you to see the change in state and kind of how they behave. So I'm going to turn on the R58 device, okay, and you can see now that with just the sensor mounted on the rail, I'm generating that electromagnetic field. I'm applying 8 volts. It's coupling into the head of the rail where it sees mass and density and so forth, and this creates a damping effect. And so the voltage we're currently measuring across the pair looks to be in the range of about 4.5 volts. Okay, and over here you can see again just above 4 volts on 2 volts per division. So again, we apply our 8 volts, and now of course we have the sensor coupling into the head of the rail. Now we have to adjust it. So now what I'm going to do is I'm going to take this guy here, okay, and hopefully you can see this, but this is graduated in millimeters. And so for example, there's 48 millimeters, then 47, 46, I'm going to adjust it to approximately 45 millimeters, okay. I take this and you'll note there's a groove in it here. I'm going to slide it over this little ridge at the center of the sensor. I'm going to push this until the test plate, the SSPV1 test plate, just kind of aligns with the gauge side of the head of the rail. Okay, so you don't want it to be touching the head of the rail, but you do want it kind of lined up if you look vertically downward with the edge. So this guy is now sitting on top, okay, and of course my R58's turned on. And my voltage has changed ever so slightly, but maybe gone up half a volt or so. Now what I'm going to do is I'm going to take this device and I'm going to pull off these nylon nuts, these retaining nuts. Okay, that prevents debris and so forth from pushing up against those spring-loaded ports where it might allow the sensor to vibrate out of adjustment. So you want to hang on to these nylon nuts. Take this guy, push him up into the tuning port. Release the spring. Okay. Now what I'm going to begin to do is I'm going to begin to increase the sensitivity of the sensor until this guy just turns on. Okay. And you can see I just turned on here. Okay. So I bring it up till it turns on, I back it off a little bit, and then I go ahead and bring it right back up till it just turns on at S1. So S1's adjusted. Same thing for S2. I'm going to take this, okay, push it into the tuning port. Now watch the meter, okay, and watch the red LED. So I'm going to turn this on until the red LED just illuminates. Back up a little bit, bring it up slowly. Okay, now they're both turned on. So now I've hit the turn on threshold for the switching amplifier module, or in this case the R58. And you can see it's approximately 6.6 volts on this meter. Same thing on the oscilloscope, it's just over 6 volts. It shows maybe about 6.2. So you're in that range of about maybe 6.4 volts roughly. Okay. Now I can go ahead and back this off. You'll see it change, right? Red LEDs go out. I'm going to bring it back, and they should turn on at roughly the same time. Okay. So they both turn on at 45 millimeters. So you can kind of see how the sensor behaves. I'm going to run a trowel across it and watch the oscilloscope. You can see the waveform here. Okay, I'll go a little slower. Okay, you also watch on the meter over here. Now, one of the things you'll notice about the sensor is it has a very sharp rising edge and trailing edge. And a good wheel sensor, a well-designed wheel sensor, will offer a very easily processed analog waveform. Okay, so we have a very sharp rising edge and a very sharp trailing edge. Okay, almost like a square wave, but on the analog side of the switching amplifier module. The trick is to provide that same consistent waveform, whether this is temporarily immersed in storm water, or whether it's minus 30 degrees Fahrenheit outside, or plus 120 degrees Fahrenheit, or maybe minus 35 Celsius or centigrade, and plus 35 or 40 or 45 degrees centigrade. So the idea here is wide temperature range, snow, ice, you still have the same consistent waveform for that wheel flange. Okay, or actually as the wheel flanges pass over. So that's basically the process. So just to review, you need the correct R58 device. It has to have good charged batteries in it. So you're providing the correct voltage. Okay. Next, you need an SSPV1, and you need either the EW1 adjustment tool or the little adjustment ferrule that's provided with the sensor. And of course, you don't need the meter or the oscilloscope. That's just there for demonstration purposes. Set this to 45 millimeters. Place it on top of the sensor. Okay, line it up. Okay. And then again, just go ahead and adjust these ports. Push this in first for S1. Okay, release the locking cam against the spring. Adjust it until it just turns on. Okay. Same thing over here. Adjust it until it just turns on. And you're all done. At the end, remember to put these back on. And you have yourself a properly adjusted 200 series non-vital sensor. Now, if you have any questions, you're welcome to call Pintsch North America. Telephone number is 618-993-8513. Thank you so much for your time, and again, please let Pintsch know if there's any questions. Thank you.